Welcome along to our final deep dive in the Cooperative AI Notes series. This is episode 8.
Yep, the last one. It's been quite a journey through the first 7, hasn't it? We started with the basics of cooperative AI.
Then got into game theory, multi-agent reinforcement learning, all that foundational stuff.
Yeah, exactly. And we didn't shy away from the tricky parts either. AI, safety, ethics, governance.
Right. And those complexities like collusion or even subtle communication, that steganography idea.
And the need for some kind of shared rules, that normative infrastructure we talked about.
So it's been a pretty thorough exploration. And today, for this final deep dive, we're looking at Unit 8, which is all about improving human cooperation with AI, specifically how it might help democratic decision-making.
That's the plan. We want to pull out the key ideas here, talk about things like the AI Economist, look at the risk, especially with LLMs and collective decisions.
And importantly, cover the safety measures and advice for you folks out there who are actually building these safe AI systems.
Precisely. And since this is the finale, we really want to point you towards digging deeper. The Cooperative AI Foundation is a great starting point, and check out the links under each deep dive. Learning more about safe cooperative AI is, well, it's crucial.
Absolutely. Okay, so let's jump in. Cooperative AI for democratic decision-making. What's the core idea here?
Well, the basic thought is pretty exciting, really. How can AI be a supportive tool? How can it help us humans cooperate better within, democratic processes?
Okay, got it. The source material had some examples, right?
Yeah, a couple interesting ones. The first imagined a cooperative AI platform, a CAI platform that could take in all the self-reported national sensor data.
Sensor data, like environmental data, things like that.
Exactly. Environmental, maybe health stats, economic figures, all sorts. The AI would then standardize it, make it comparable across countries.
Okay. So leveling the playing field for the data itself. What then?
Then the really neat part, it compares that data against international commitments. Think climate agreements, public health targets.
Oh, I see. So it flags where things aren't matching up.
Precisely. It highlights progress, but also conflicts, discrepancies, potential violations. An international body could then use this to monitor things more effectively, address urgent problems. It adds a layer of data-driven transparency.
That's a powerful concept.
Yeah.
Using AI for global accountability. What was the other example? Something more local?
Yes, focusing on state-level policies, tackling unemployment, improving economic well-being, that kind of thing.
How would AI help there?
The idea is you'd build a CAI simulation model using the state's specific data, economic, labor, education stats.
So like a digital twin of the state's economy almost.
Sort of, yeah, a virtual testbed. Then, policymakers could simulate different interventions, new training programs, maybe different subsidies.
And see what happens in the simulation before rolling it out for real.
Exactly. See the likely impact on employment, on income, maybe even for specific demographic groups. The state employment board or whoever could make much more informed choices. It's about testing policies safely first.
Makes sense. Less guesswork, more data-driven strategy. Okay, let's shift gears to this AI Economist. Sounds intriguing. What's that about?
Right, the AI Economist. It's a pretty advanced framework. It uses what's called two-level deep reinforcement learning.
Okay. What's it trying to achieve?
The main goal is to train AI social planners to discover tax policies, but not just any tax policies, ones that can really effectively balance economic equality and productivity in dynamic economies.
Whoa. So it's not just observing, it's designing economic policy. That's ambitious.
It is. And a key difference from, say, traditional economic modeling is that the actors within the simulation, the little AI agents representing people or firms, they're also learning. They adapt their behavior based on the economy and, crucially, based on the tax policy the AI Economist sets.
So it's a feedback loop. The policy changes behavior, and the behavior informs the next policy tweak.
Exactly. It's this dynamic, adaptive system. And here's the kicker. Neither the AI Economist nor the agents start with any knowledge of economic theory.
None at all.
Nope. They learn purely from the data they see inside the simulation, which means it can potentially discover policies that, human economists might not have thought of.
That's fascinating. And the results, the outline mentioned improvements.
Yeah, some studies showed really promising results. One indicated, I think, a 16% improvement in that trade-off between equality and productivity compared to baseline policies, even established ones like the SAES framework.
16% is?
Yeah, well, that's significant. Did the AI design policies look different?
Often, yes,
Yeah.
qualitatively different. A common theme was finding policies with maybe a higher top tax rate, but also higher net subsidies for lower incomes. It suggests the AI might be finding leverage points that aren't obvious in traditional models.
Interesting. Were they stable? Could the agents in the simulation just learn to game the system?
That's a great question. The research suggests they actually showed pretty good resilience. Even when the AI agents learned tax gaming strategies, the AI design policies tended to hold up reasonably well.
And they even tested this with real humans, right, on MTurk. They did. Those experiments suggested the AI policies could achieve a similar equality productivity trade-off to the SEA's framework, but with higher inverse income-weighted social welfare.
Which means?
Basically, it suggests a greater positive impact on the well-being of those with lower incomes in the experiment. It hints that these AI insights might translate into real-world benefits people value.
It really shows the potential, doesn't it?
Yeah.
Okay, the outline mentioned the technical side, partial observable multi-agent Markov games. Can you simplify that?
Sure. Multi-agent just means lots of AI actors. Partial observable means each actor only sees part of the picture, like us in the real world, right? We don't have perfect info.
Hi.
And Markov games, that's just the mathematical framework for how these agents make decisions over time, where the future depends on the present state and everyone's actions. It's a way to model these complex dynamic interactions.
Got it. And the agents have different skills affecting income.
Right, reflecting reality. And the AI economist, the planner, sets the tax brackets and the marginal rates within those brackets. It learns to do this using techniques like PPO, proximal policy optimization, trying to maximize that social welfare function, which can be tweaked to prioritize equality or productivity.
And it's often open source.
Yeah, the underlying code often is, which is great for encouraging more research in this area.
It's amazing tech. But let's pivot now, because with great power comes great responsibility, right?
Yeah.
Let's talk about the risks, especially using large language models, LLMs, for things like preference aggregation and collective decision-making.
Absolutely crucial topic. LLMs are incredible, no doubt, but using them for something this sensitive. Yeah, there are significant risks we need to be aware of. One core issue is that their System 1 thinking fast pattern matching sometimes overrides their System 2 slower deliberate reasoning.
So they might give a quick, plausible answer that isn't actually deeply reasoned. What kind of specific risks does that lead to?
Well, number one is probably hallucination. LLMs can just make stuff up. Plausible sounding, but wrong or nonsensical. If you're relying on that to understand what a group wants, well, you can see the problem. Flawed decisions based on phantom preferences.
Yeah, that's scary. Basing policy on generated fiction. What else?
Bias. This is huge. LLMs train on massive data sets, usually scraped from the internet, which is full of societal biases. The models can learn and even amplify these biases. If you use a biased LLM to aggregate preferences, you risk unfair or discriminatory outcomes.
And just basic safety and alignment, right? Ensuring the LLM doesn't generate harmful or toxic stuff when processing opinions.
Critical. Plus, you've got adversarial attacks. People can try to trick the LLM with carefully crafted prompts, prompt injection, jailbreaking to bypass safety filters or manipulate the output. Imagine someone deliberately skewing the perceived collective preference.
That's worrying. The potential for deliberate manipulation. The outline also mentioned goal drift and emergent behaviors.
Yeah, goal drift is the idea that the LLM's internal goals or behaviors might shift over time, moving away from the intended purpose of fair preference aggregation. Emergent behaviors are just unexpected things complex systems start doing. They might not be harmful, but they could be, especially in a sensitive context.
And handling all this preference data. There must be privacy risks.
Definitely. You're potentially feeding sensitive user opinions into these models. That raises big questions about data security, who has access, unintended logging by the provider, and the risk of leaks or misuse.
Plus, it's often hard to know why an LLM summarized things a certain way, isn't it? Transparency and explainability.
Exactly. They can be black boxes. If you can't understand the reasoning, it's hard to trust the output or even identify if there's an error or bias creeping in.
And finally, the risk that LLMs could just make traditional manipulation easier and more effective.
That's a real concern. They could be used to craft highly targeted, persuasive misinformation, streamlining efforts to sway public opinion or collective decisions unfairly. So yeah, lots to be cautious about.
It really underscores the need for robust safety practices. So let's talk about that. What are the key safety measures and the advice for you folks building these cooperative AI systems, especially with LLMs involved?
Okay, first and foremost, you need a solid grounding in AI safety fundamentals. That includes ethics, governance. It's not just tech, it's the whole picture.
Right, a foundational understanding.
Yeah.
What practical steps follow from that?
Conducting thorough risk assessments. Really thinking through upfront what could go wrong, what are the potential safety issues, the ethical concerns, especially with LLMs.
And presumably, getting other eyes on that.
Yes, external expert scrutiny is invaluable. Getting feedback from people specializing in AI safety and ethics can catch things you might miss.
Then when it comes to actually deploying the system,
You need robust deployment safeguards.
Yeah.
Think phased rollouts, maybe, close monitoring initially, clear ways for humans to step in if needed.
and that monitoring isn't a one-off.
No, definitely not. Continuous monitoring is crucial. Keep watching the system's behavior and outputs over time. Look for those unintended consequences or harmful patterns emerging.
Given the data involved, information security must be paramount too.
Absolutely critical. Protecting training data, the models themselves, user data. That needs top-tier security against breaches and threats.
What about watermarking AI content? Does that help here?
It could. Exploring and using watermarking can boost transparency and help trace where information came from, which might help combat LLM-generated misinformation.
And the field needs to keep pushing on safety research, right?
Definitely. Investing in safety research, contributing to developing safety standards and best practices, that collective effort is vital.
What about regulation?
That's part of the picture, too. Giving regulators appropriate visibility, ensuring compliance and enforcement mechanisms exist, potentially considering targeted regulation based on model power, but also ensuring these measures don't stifle smaller players. There's even discussion around differential progress, maybe deliberately pacing certain capabilities based on safety readiness.
And that idea of a normative infrastructure for AI seems key for cooperation.
It really is. Building systems that understand and follow principles of fairness and appropriateness. Plus, always having human oversight where decisions are high stakes. Transparency about data use is non-negotiable. Developing robust security frameworks for LLM-specific vulnerabilities, providing proper AI security and privacy training, having clear acceptable use policies, documenting data sources, using threat modeling, and employing rigorous evaluation metrics. It's a whole suite of practices.
Wow, okay. It's clear that building safe cooperative AI, especially mixing in LLMs, isn't simple. It's a continuous, multi-layered effort.
It really is. It demands technical skill, proactive risk management, and a deep commitment to ethical development. As these tools get more powerful and integrated, especially in areas like democratic processes, getting safety right is just fundamental.
Well, that brings us to the end of this deep dive, and actually the end of our entire Cooperative AI Notes series. We've gone from the potential of AI, like the AI Economist, to boost decision-making, all the way to the really critical safety considerations around LLMs.
Yeah, we hope this whole series has given you, especially those of you building these systems, some valuable perspectives and a clearer view of the landscape. It's a field that's moving incredibly fast, and focusing on safety and ethics is, well, it's paramount for making sure it moves in a good direction.
Absolutely. And please do check out the resources we've mentioned, particularly the Cooperative AI Foundation. The links under each deep dive are there for you to continue your learning.
And maybe just one final thought to leave you with. As AI gets better and better at modeling complexity and potentially guiding collective choices, how do we make sure the rules, the normative frameworks we build into them, genuinely reflect the diverse values of a democratic society?
That's a deep question. Definitely something to ponder as you continue your work. Thank you so much for joining us for this deep dive and for the whole series. We hope it's been useful.